So moving on to this next one, again, we have to try, is it standard integral? No. Is it substitution? No. Can I rearrange it? No. I should try product. I should try integration by parts. There are pieces in here that I can choose. Now the way I choose it, I have to choose a U piece and a dV piece. And the way I choose it is I need to select the dV part to be the most complicated part that I can integrate. So my choices would have been e to the x dx or x squared dx as my dV piece. Well, x squared dx I can integrate, no problem. E to the x 2x I can integrate as well, and this one is more complex than the x squared version of it. Okay, so I'm going to choose that one as my part. So when I write out my integral, my original integral pieces were e to the 2x, okay, dx, that's that part, and my x squared part, and I'm going to break it up into the new parts. So it's going to be uv on the outside of the integral, and then this is a key part. This is a part that is the make or break. Okay, this new integral that I end up with. Okay, so the parts I used were the u dv. I generate the other parts by differentiating. I integrate this to get the other part. There's my integral. So the new part that I'm going to integrate, or hopefully can integrate, is going to be e to the 2x over 2, 2x dx. Okay, and I can simplify that out. And unfortunately, in this case, that new integral can't be done. Okay, so this cancels out, and I end up with x e to the 2x dx. So this can't be done. However, when I look at what I started with, this is a little bit better. And it's essentially the same form, which means then why can't I reapply integration by parts again? In fact, I can. Okay, and I'm only going to apply it to the integral. So this part's been resolved. Okay, but I can reapply integration by parts on this piece right here. And again, I can just break it into parts. I need a u part, okay, and I need a dv part, which is the most complicated part that I can integrate. Well, I already chose that as my dv part. Okay, so my dv is equal to e to the 2x dx. That means that my u part must be this part here, so u equals x. That's easy to differentiate to get my du. That dv part, I can integrate it to get v. V is equal to e to the 2x over 2. Again, I can now plug it into my formula. I've got my x, my uv, so my u times v as part of my formula, okay, just like I had it here. Okay, so but I'm going to put this in brackets, make sure that I have in brackets, because that part is a new integral which I'm reapplying integration by parts to. So e to the 2x over 2. And then my new integral minus, okay, so this is applying my formula, uv minus v du. Okay, so my new v here, and I'm generating my new integral, and du is going to be dx. So here's my v du. So sorry, my du is dx. Okay, so again, all I've done is taken an old integral, rearranged it into this, and I generated a new integral. And this new integral now I can integrate. Okay, so although I had to apply it twice here, I had to apply integration by parts twice, I did end up with a new integral that can be integrated right there. Okay, So now I can resolve this integral. X squared e to the 2x over 2 minus x e to the 2x over 2. Okay, and I forgot to, no, those cancel out. So, and then I end up with plus, negative is a plus. The integral of that is going to be e to the 2x over 2 divided by 2. So I'm going to get over 4 and then plus c. Okay, just watch out for the signs because that's a negative. It's going to change, flip it over. But there it is. There is the integral of that. Okay, this is my original function. There is the antiderivative of that function.